Very good morning, students. Today we can start a new topic, that is of 11th class, but friction in solid and liquid. Okay, so this topic we are delivering, we are taking for the crash course point of view and for the CET students. Okay, so for that CET there are the 4 chapters from the 11th class, and one of the chapter is the friction in solids and liquids. Okay, so now first of all we can say what is exactly friction. Friction means what exactly? So friction is the force. Actually, what is that? Friction is the force between the two surfaces which are coming in contact with each other. Okay, and that force which acts tangentially on one surface over the another surface. Okay, so that is called as the frictional force. Again, I will define what is the friction. Friction means nothing but that means it is one type of force which causes between the two surfaces which are coming in contact with each other and which acts tangentially along the each surface. So that is called as your frictional force. Okay. Once you got that force of friction, okay, that friction actually opposes the relative motion between the two surfaces which are coming in contact with each other. Then question arises, sir, suppose one body is moving over the another body. Okay, then why that force of friction opposes the relative motion between the two surfaces which are coming in contact with each other? So that is the cause of friction. Then question arises, why these things happens? What is the cause? What are the causes of that force of friction? Basically, there are two causes are there. First cause is roughness of surfaces. Okay, roughness of surfaces which are coming in contact with each other. Okay, roughness. Okay, or due to that two surfaces which are rough. Okay, or roughness of two surfaces. Okay. So then what happens, what is the roughness means if the surface is rough or due to that roughness of that two surfaces, how that force of friction is causes. Now it's a very simple, you see here, suppose though that means you can see here one surface will be like this. Okay, so I will say suppose this surface is like this. Okay, so this is the surface. Okay, then now what happens, the another surface will be like this. Okay, so here in that case what happens, here in that two surfaces. Okay, so suppose this is the first body and this is the second body. Now here for both the bodies there are the heels and deals are there. Okay, means depression and heels. Okay, upper part, lower part, upper part, lower part. Okay, here also lower, upper. So then what happens, one heel is come in contact with the deal, one heel coming in contact with the deal, and so therefore when one body moves over the another body, okay, so this is the surface 1, this is the surface 2, and now in surface 1 and surface 2 there is interlocking is going on between the two surfaces which are coming in contact with each other. And when that interlocking is going on, so there here at this particular point it will be acts like as a cold welding. Okay, in welding the two surfaces they are connected with each other. Similarly, here also that two surfaces they are coming or that means contact with each other. And so when they are contact with each other, so therefore it is very difficult when one body is moving with the another body, so that motion will be get opposed by that interlocking. So that is the roughness of two surfaces. Though sometimes we feel the surface is very smooth, sir, but the surface is smooth, still there will be a force of friction between the two surfaces which are coming in contact with each other. So how these things happens here now? If there will be a smooth surface, but still there will be, that means your frictional force will be causes here. But how, sir, these things happen? It's a very simple. Though you can see that means roughly along the superficially on the upper part of that surface, though you can see that is the very smooth, but by your microscope, if you will observe that surface, so then there will be heels and deals are there, irregularities are there for that surface, that which we cannot see through the naked eyes, but through the microscope you are able to see that things. Okay, and due to that that means your what we can say, so that is the irregularities, there is interlocking is going on, and so therefore it will be causes the force of friction. So that is the first reason. Second reason for that is there is a strong intermolecular force of attraction is there between the two surfaces, or strong atomic and strong atomic and molecular force of attraction, between two surfaces which are coming in contact with each other. Okay, the strong atomic and molecular force of attraction between the two surfaces in contact. So this is the another reason. So here in that case, what happens, so when one surface is, that means moves over the another surface, so the molecules of the first surface, they are attracted by the molecules of the second surface, and there is a strong force of attraction, molecular force of attraction is going on between the two surfaces. When one surface is attracted by the other is also attracted by the first surface. So it's like this. And so here also there is interlocking is going on. So that is also type of cold, that means welding. And so therefore, when this one surface moves over the another surface, so there will be the force of friction is going on between the two surfaces which are coming in contact with each other. So these are the two causes because of that force of friction, that means friction, that because of that roughness or strong atomic and molecular force of attraction, there will be friction in solid. Okay, once you got that things, then question is that like this, sir, why that frictional force is called as self-adjusting force? Okay, frictional force is called self-adjusting force. Okay, what is the reason behind it? Self-adjusting force, what is the reason behind it? Okay, very simple. Now what happens, see here, that what is that force of friction exactly? Now when the one body moves over the another surface, okay, one body moves over the another surface, then at that time what happens, the force means body is moving in the forward direction, force of friction will be always acts in the backward direction of the body. Okay, and when the body changes its direction, suppose this body is moving now on that surface like in this direction, then what is going to happen, force of friction adjusts itself in opposite direction of forward motion of the body. Means now here I don't have to change the direction of the body, force of friction. So as the body moves in the forward direction, force of friction that means acts along the backward direction. Okay, because it will opposes that motion between the two surfaces which are coming in contact with each other. But now if body has been turned towards the another side, then the force of that means friction will adjust itself along the opposite direction of, that is the motion of body. So therefore it is also called as self-adjusting force. Okay, why the force of friction is called as the self-adjusting force? That force of friction is also called necessary evil. It is also called as necessary evil. Okay, what is the reason behind it? Why force of friction is called as necessary evil? Okay, so now reason for that is necessary evil means, why we can say that force of friction is necessary evil? Necessary evil means student, means it sometimes we require that force of friction, sometimes we don't require that force of friction. Means here when we can say that force of friction will be required, suppose in day-to-day life force of friction is very important for us, because we are able to walk on the earth's surface because of that force of friction. Because when I am applying the force on the ground, so as this is the roughness of the two surfaces are there, ground and our leg, our shoes, then what will happen? There is interlocking is going on, and so therefore we are able to walk very properly because of that force of friction. Therefore it is necessary. But another point is that because of excess force of friction, there is wearing and tearing is going on between the two surfaces when we are coming in contact with each other. When the tire, that means a vehicle's tire, is moves on the road, sometimes tire is going to get tear. So this is due to the excess frictional force. Okay, so therefore this is considered to be evil. It will dissipates the more energy. Okay, means more energy is required to move the one surface over the another surface because of force of friction. Means there will be the waste of energy. So therefore we don't want that. So therefore it will be acts like as a evil. Okay. Again, it will produces the heat. Okay, so that force of friction produces the heat. So these are the disadvantage we can say for that force of friction. And so therefore, that means day-to-day life we are able to walk because of that. But moreover, there will be some efficiency of that machine can be reduced because of that force of friction. Okay, dissipation of energy is going on, energy lost, efficiency lost. So therefore, this will be acts like as a evil. So therefore, it is called as necessary evil. Okay, force of friction is also called as necessary evil. Now question is how we can reduce the force of friction. Okay, because now if it is the necessary also, it is acts like as a evil also. So then now question arises, how we can reduce the force of friction. How we can reduce the force of friction. Okay, so that is the next point. So now, so see here, force of friction can be reduced by polishing the surfaces which are coming in contact with each other. By polishing the surfaces. Okay, you can polish the surface by polishing the surface. You know, sometimes if the surface is rough, then you can just polish that surface and make it smooth, so that force of friction will get reduced. Okay, so then whatever the required only force of friction, you can keep it as excess force of frictions can be reduced by polishing the surfaces. Second thing, by using the proper lubricant. Okay, by lubricating or by using the lubricant. By using lubricant, okay, we can reduce the force of friction. We can reduce the force of friction. We can reduce force of friction. Means you can do what you can do. You can use the proper lubricant. So which are the proper lubricant? Sometimes we are using the grease. Sometimes you can using the oil. You know, if you want to for bicycle, for the chain you are using the oil. So that is the lubricant. Okay, when you are doing or servicing your vehicles, then that time for the brakes, handles, they are using the grease. So that is used as a lubricant for the machineries. The proper lubricants according to the temperature we are using. So that is the lubricant. By using the proper lubricant, you can reduce the force of friction. But then by using the dissimilar materials, okay, by using dissimilar materials, okay, we can reduce the force of friction. Okay, sir, by using the dissimilar materials means what, sir, exactly? Because if the two surfaces of same material, so there will be more force of attraction will be there. Okay, but if you are using the different surfaces, the force of attraction will get reduced. So therefore force of friction will also get reduced. So therefore while you are using the dissimilar materials, so then the force of friction will get reduced. Okay, and appropriate shape of the bodies. Okay, by selecting appropriate shape of the body. Okay, if you want to use that body should run over the another, then appropriate shape of the body has to be choose. So then what is the meaning of appropriate shape? You know, sometimes we are using the ball bearings. Okay, the shape of bearings will be circular form. So that you can select the such a shape, so that force of friction will be automatically get reduced. Okay, and now suppose the machineries are made up of iron, then you can use the ball bearings which is made up of steel. Okay, so the steel material can be used for that bearing point of view. Okay, or we can say that metal balls for the that your chain, they are the metal balls, small spherical balls are there, they are the steel balls, but the chain is made up of iron. So the different materials you can use and shape of the material should be a proper circular shape. So that what happens, so then automatically this force of friction is going to get reduced. Okay, material, if you are using the different iron and steel, the force of friction will be, that means force of attraction between the two different materials will be less. So therefore, as compared to the two similar materials, force of attraction here will be less, and so therefore force of friction can be reduced. Moreover, instead of using a different shape, you can use the proper shape, appropriate shape, so that the force of frictions will be going to get reduced. Okay, so these are the how to reduce the force of friction. Okay, so once you are getting that why the ball bearings have been used the machinery to reduce the friction, but then the reason is very simple. I have already explained to you that bearings particularly are used to reduce the force of friction, and if you are using the different materials, then force of friction will be less as compared to similar materials. So therefore we are using the ball bearings of different materials. Okay, so now once you got that this thing, then what are the advantage of force of friction, sir? Okay, so this is the how we can reduce the force of friction. Then now next point is what are the advantage of force of friction? Okay, necessary point, necessary will make. So what are the advantages? Only just we are able to walk, this is the advantage? No, sir. There are so many advantages are there of force of friction. Advantages of force of friction or frictional force. Okay, so can you tell me what are the different advantages of force of friction? So now, first of all, first advantage is which I have given, we are able to walk on the earth surface. We are able to walk on the earth surface. This is due to force of friction. Okay, if there will be no force of friction, and if like as ice, if somebody will ask you please walk on the ice, so then it will be very difficult because surface is smooth, there is no friction between your leg and the ice, and so therefore you will slip on that slippery surface. So therefore that surface should be little bit rough, means we are able to walk on the earth surface because of that force of friction. Second advantage is we can chew the food. Okay, we can chew the food. Now sir, chew the food means what exactly, sir? What exactly we are doing? So now suppose if you are taking the food, when you are eating, then at that time between the two teeth that food is going to get crunched, okay, or it will be get crashed, and so therefore because of that force of friction, that food, that means it will be a smaller part, and then we can digest it properly. We can chew the food because of force of friction. If it would have not been there, then you would have not eat it properly, that food. Okay, so that is the another point. Okay, we are able to fix the nail. Okay, we are able to fix the nail into the wall, this is because of force of friction. If the wall, there will be no force of friction, then the nail would have not been, that means goes inside the wall. So therefore there should be, that means we can fix the nail into the wall because of that force of friction between the nail and the wall. So that is the very important. Okay, then the moving vehicle can be suddenly stopped. Moving vehicle can be suddenly stop by applying the brakes, okay, means what happens, suppose you are driving your bicycle, you are driving your vehicle, car, then as soon as you are applying the brake to that car, brake to that cycle, brake to that vehicle, then automatically there will be, due to the force of friction that between the tire and that brakes, so the tire is going to get stopped there. So therefore you can make, that means your vehicle is going to get stopped because of force of friction. You just, that means imagine the situation. If the brakes are not applying properly, brakes are not working properly, then what will be the things is going to happen? If the brakes are not going to apply, that means they are not work properly, then there may be a chances of accident, because then we cannot apply that brake, the vehicle cannot stop, then there would have been accident. So therefore force of friction will be playing the important roles here in all the cases. Okay, so that is the advantages of force of friction. Okay, so then sir, what are the disadvantages of force of friction? if these are the advantages, because one another point, if it is advantages, then there are some disadvantages are also there, because necessary evil also there, disadvantages. Okay, disadvantages of force of friction. So now you see that first of all, first disadvantage is it will dissipates, force of friction dissipates the energy, dissipates the energy. Okay, means there will be loss of energy, there will be loss of energy, or it will be reduces the energy, reduces the energy. Okay, loss of energy. Okay, dissipation of energy, reduces the energy, loss of energy, anything you can say. These things happens because of force of friction. Then next is the efficiency of the machine is going to be decreases. Efficiency goes on decreasing, because of force of friction. That is also one of the disadvantage. Okay, means whatever the output upon input, that ratio if you can see. So you are giving too much input, but you are not getting that much output because of that force of friction. It will reduces that energy, therefore output will be automatically goes on decreasing. So therefore efficiency goes on decreasing. Okay. The next point, heat is produces. Okay, because of force of friction, heat is going to get produces. Then now next point, there will be wearing and tearing is going on. Wearing and tearing of surfaces is going on, wearing and tearing of surfaces. So that is also one of the problem which is going on because of that force of friction. Okay, so that is also disadvantage of force of friction. Okay, now once you got that force of friction, then now, so then question arises. Okay, in the form of, so he has also given that part of the energy, whatever the energy you are utilizing, so part of the energy is used to, that means for what purpose, machine is, that means used in the form of producing the heat. So that is also disadvantage. Now question is, sir, what are the different types of friction? Okay, what are the different types of friction? Okay, so now we can proceed to the types of friction. Types of friction. So now you see here, there are mainly two types of friction. Okay, one is static friction and second is dynamic friction. Dynamics means when the body is in motion and static means when the body is in the rest position. Dynamics further classified into two types, that is kinetic friction, and second is rolling friction. So then, sir, what are these types of friction? So again I will define what is the friction. Friction is the force between the two surfaces which are coming in contact with each other and which acts tangentially across or along the two surfaces which are coming in contact with each other. So that is the friction. So there are how many types of friction? Basically two types, statics and dynamic. Static friction means, sir, what is static friction? Static friction means when the force of friction acting between the two surfaces in contact at rest. What is the static friction? Force of friction which is acting between the two surfaces when they are at the rest position. So that is called as the static friction. Static itself is name is given. So that is, suppose this is the body which is lying on that surface. So now this body is touching to that surface, but body is in the rest position, surface is also already in the rest position. So then for whatever will be the, that means your force applied, but the body is not going to move in the forward direction. Then at that time, why this body is not moving? Because of that static force between the two surfaces which are coming in contact with each other. Okay, so that is the static friction. Then now dynamic means that means your vehicle is now moving in the forward direction. So therefore dynamic means it is in motion. Okay, and static means when the surfaces are in rest. But motion means what now? So there are two types. Now kinetic friction. In kinetic friction we can say that the force of friction between the two surfaces in contact, when the force of friction between the two surfaces in contact, when one surface starts sliding over the another surface. Here which motion is going on? Just starts sliding over the another surface. One surface is sliding over the other surface. Okay, then at that time, whatever the force of friction will be there, so that is called as the kinetic friction. Now what happens, initially the large force is required to move that body on that surface, so that is the static force. That is also called as limiting static force of friction. Okay, means more force will be required. But once it will start moving, then it will require less force as compared to static force, and then this body starts sliding over the another surface. And now, sir, what is the rolling force of friction then? The rolling force of friction means the force of friction between the two surfaces is contact when one surface is rolling over the another surface. Means here the one surface rolls over other surface, so that is the called as rolling force of friction. Then at that time the force of friction which comes in contact, so that is called as a rolling force of friction. So therefore kinetic force of friction and rolling force of friction. When the sliding, kinetic; rolling, then now when the body starts rolling, then there will be again less force will be required, so that is called as the rolling force of friction. Means somebody has asked me, sir, so arrange this force of friction, then I will say static force of friction will be more as compared to kinetic force of friction, as compared to kinetic is more as compared to rolling force of friction. Okay, so that will be the your sequence. Static is more than kinetic, kinetic is more than rolling. This is like a simple example I will give to you. Suppose one student, he don't want to study, and if the teacher is forcing him, then first of all to go inside the book he will require, that means more force, because he don't want, but we are still forcing him, you please go. Once he starts inside, even once he enters into that book, then now he don't require more force. Okay, automatically once he is interested, he starts reading the book, means this will comes in kinetic. And once he know everything now, then he will starts running into that books, means he is interested into reading the book, solving the problem, and so that will be acts like as a rolling force of friction. Okay, so this is the sequence of static, kinetic and rolling force of friction. Now question is, sir, what are the laws of force of friction? Okay, laws of force of friction. So then these are the laws for static friction also, and the laws for that is the kinetic force of friction also. So therefore we can proceed for laws of static force of friction. Laws of static force of friction. So particularly there are the three laws are there for kinetic as well as for the your static force of friction. Okay, so now sir, what is that laws of static force of friction? So the first law is this law states that the static force of friction is also called as limiting static force of friction. The limiting static force of friction, Fs, is directly proportional to its normal reaction. So what is the meaning of that statement? Now you see here, suppose this is the surface, and on that surface, suppose this is the body. Okay, this body is lying on that surface. Now what happens, if I will that means apply or connect the string to one end of that box, and another string has been passed over the pulley. Okay, it has been passed over the pulley, and at the floating end of that string, that means it has been passed over the pulley, I have connected one pan. Okay, and in that pan I will connect that means put the weights here. Now what will happen, whatever the wooden block which has been kept on the surface, the weight of the wooden block which is acting vertically downward direction, so that is the mg, and the normal reaction provided by the surface on the block will be, that is the normal reaction n. Okay, that is also sometimes you can call it as a r also. Okay, so that is the normal reaction. Then what exactly we have to do? If you are putting some weights into the pan, okay, if suppose smaller weights has been put into the pan, then this box will start just sliding over the surface. Before sliding, will move on that surface. But first of all, if I put 1 gram, 2 gram, 3 gram, so here in that case, this block is not going to move, so that is the limiting static force of friction. Okay, but at one particular point the box will, that means your block will show little bit, that means motion, and so therefore that will call as the force of static friction. Okay, so now the first reading I will take. So suppose this is the Fx is equal to some constant, and that is called as the coefficient of static friction, or we can also that coefficient of static friction is equal to force of static friction divided by normal reaction. Now in first case I will do the same thing. Okay, so like this you can take the different readings. Now how we can take the different readings now? So first case we can take some force F1, okay, F1 and then normal reaction, so that force you can calculate. Next case I will put some weight on the block, and then now to move the block again we have to add some weight here. So now that will be the second case. Mu s is equal to F2 upon N. Okay, F2 upon N. Okay. Similarly, you can put again more weight on the pan. Again you have to add the weight into the pan, but you will find F3 upon N. And here in that case, F1 upon N is equal to F2 upon N is equal to F3 upon N. So all these forces means that ratio that is called as the your constant, that is the mu s. Okay, so that is the coefficient of static friction. Okay, or we can also that Fs, force of static friction upon normal reaction, is equal to mu s, or we can prove here force of static friction is directly proportional to mu s. Okay, so that is the your first law can be verified. Okay, again I will define what is the first law. Limiting force of static friction is directly proportional to normal reaction. Okay, so that is the your verification of first law also, and that is the first law of static friction. Okay, limiting static force of friction between the any two surfaces is directly proportional to its normal reaction. Okay, so that is the first law. What is the second law, sir? Second law states that, okay, so this is the first law. Now we'll go for second law of static force of friction. What is the second law? So now in second law, what we can say that the force of limiting static friction Fs does not depends upon the area of contact between two surfaces. Okay, between the two surfaces. Means, sir, what exactly? Means suppose you see here, in law second, okay, what that law is telling. Now instead of this body, if you are taking like this, you just take this body, you keep in, instead of putting like this, I will keep the body here like this. Okay, like this. So instead of this more surface area, I will take the less surface area which is lying on the body. Now you see here, though that here in that case the area which is coming in contact with the another surface of the block will be less as compared to first case. But still the force of friction will be the same. Means your weight which is required to move that block will be remains the same. Okay. So now here in that case we can also say that so here whatever the area you have kept, so it does not depends upon the area of contact. Okay, force of static friction does not depends upon the area of contact between the two surfaces which are coming in contact with each other. Still the force of friction will be remains the same. Why these things happens, you know? Because though you are changing the area, weight will be remains the same. So therefore normal reaction will be the same. So therefore again Fs is directly proportional to N. So therefore it does not depends upon area. And now third law states that, so then on what point or what conditions, that means the force of static friction depends. So it depends upon nature and material of the surface of contact. Force of static friction depends upon the nature and material of surface which are coming in contact with each other. Material and surface which are coming in contact with each other. So how this is so? So you see here, if you are taking the two surfaces which are in a such a way that they are the different surfaces. One is glass, one is wood. then the force of friction will be less. But if you are taking glass, then the force of friction will be more. Okay, so therefore again you can take the nature of the surfaces. If surface is smooth, then the force of friction will be less nature. If the surface is rough, then the force of friction will be, that means how the force of friction will be then it will be more. So therefore it depends upon the nature and the material which used in the force of friction. Okay, so these are the three laws are there for limiting static force of friction. Similarly, there are three laws are there, laws of kinetic force of friction. Kinetic force of friction. So these are the another three laws are there. So which are the three laws? They are similar to your laws of static force of friction. So that is the first law. First law here. This law is telling the force of kinetic friction Fk is directly proportional to its normal reaction. Force of kinetic friction will be directly proportional to normal reaction. Okay, so then that will also, we can say that Fk is equal to mu k into n, or mu k is equal to Fk upon n. Okay, so that will be the force of kinetic friction, okay, or coefficient of kinetic friction. So that is the your first law. Second law is here. Second law of kinetic force of friction states that, this law states that the force of kinetic friction is independent on area of contact between the two surfaces which are coming in contact with each other. Okay, so that is also that your second law. Okay, so this is also that force of kinetic friction does not depends upon your area of surface in contact. Third, the force of kinetic friction depends upon nature and material. The same thing again. Third law, the force of kinetic friction depends upon the nature. It depends upon nature and material. Nature and material of the surface in contact. Nature and material of that surface in contact. Okay, surface in contact. Okay, so these are the your three laws of force of kinetic friction. Means they are not different than that of the static force of friction. But remember, kinetic force of friction will be less as compared to static force of friction. Now next question is, sir, what are the coefficient of static friction and coefficient of kinetic friction? Okay, so now we can define the last 2 points. Coefficient of static friction. Coefficient of static friction, that is denoted by mu s. That is denoted by mu s. So how we can define the coefficient of static friction? As you know, according to the first law of limiting static force of friction, it states that the force of static friction is directly proportional to its normal reaction. Okay, so therefore Fs is equal to mu s into n. Okay, mu s means coefficient of static friction into normal reaction. So therefore the coefficient of static friction is equal to Fs upon n. Okay, so that is force of static friction divided by its normal reaction. So that mu s is nothing but coefficient, okay, of static force of friction. क्यों limiting static force of friction. Now, what is coefficient? I will again define. It is the ratio of limiting force of friction to the normal reaction, which is constant, and that constant is called as the coefficient of static force of friction. Okay, you remember that point. So that is here you remember one thing, the coefficient of static friction will be different for the different material. Not necessary that all the constants are the same for the different, but for that material it will be remains constant. So therefore this is called as the constant. Okay, this ratio force of static friction to the normal reaction will be always remains constant. That constant is called as the coefficient of static friction. Okay, so that is the first definition. Then now second definition is coefficient of instead of static we can say that kinetic friction, coefficient of kinetic force of friction, kinetic force of friction, that is the mu k. So that we want to define. Okay, so then now this coefficient of kinetic force of friction is defined as, so that is force of kinetic friction, or I'll rub all these things and I will define. So, as you know, force of kinetic friction is directly proportional to its normal reaction. Okay, this is also the first law of coefficient of kinetic force of friction. Okay, or that is the first law, that is kinetic force of friction. So, here also we can say Fk is equal to mu k into n. So, that mu k is called as coefficient of kinetic friction. Okay. So therefore mu k is equal to Fk upon n. Mu k is equal to Fk upon n. Okay. So then sir, define the coefficient. So here that mu k is called as coefficient of kinetic force of friction. Kinetic force of friction. So then sir, how will define that things? Again I will define. The coefficient of kinetic force of friction is defined as, it is the ratio of, which ratio? The force of kinetic friction to its normal reaction, which is always remains constant, and that constant is called as the coefficient of kinetic force of friction. Okay, so that is the your last point of that coefficient of kinetic force of friction. Okay, once you got that all these frictional force or the different types of friction, then I will give one simple example to you on that, and so that you will get the idea about how to solve this type of examples. Okay, so these are the coefficient of kinetic force of friction. So you please write down the example on that. Okay, so the first example, write down a block of mass 40 kg. Okay, numerical. So question is like this. A block of a mass, how much mass is there? 40 kg, block of a mass 40 kg, raised on the rough horizontal table, just starts sliding when the horizontal force of 125 Newton. How much force you are applying? 125 Newton. Okay, is applied to it to keep it moving with the uniform velocity. Okay, so first of all, this is the block having the mass that is 40 kg, and you are applying the force of 125 Newton. Okay, so that much force you have already applied. Now to move with uniform velocity this block, okay, it should move like this. Okay, it should run like this. How much force you will require? 80 Newton of force is, 85 Newton of force is required. So that force will be now, for running means kinetic, 85 Newton force is required. Okay. So then now calculate the coefficient of static and kinetic friction between the two surfaces. Means he has asked you coefficient means mu s also, and second is mu k also. Okay, both the coefficient he has asked to you solve. So now here in that case, first of all, we know Fs, this is the static force of friction, this is the kinetic force of friction. And I know Fs is directly proportional to n. So therefore Fs is equal to mu s into n. So therefore mu s is equal to Fs upon n. So what is that static force of friction now here in that case? 125 Newton. Okay, so that is 125. How much weight of the block is there? That is the 40 kg. Okay, that is the mass. Okay, 40 kg. But you have that is Newton, means this is the weight. Okay, so that will be n is m into g. multiplied by 9.8, or you can take 10 also, there is no problem. So 125 upon 392, because here 0, 4 8s are 32, 3 4 9s are 36 plus 36 plus 3 39, and 125 upon 392, so that will be 0.3188, 0.3188. So therefore this is the coefficient of static friction. Now second part, I want to find out the coefficient of kinetic force of friction. Okay, so what is the formula for that coefficient of kinetic force of friction? So that formula is Fk upon N, force of kinetic friction divided by its normal reaction. So the force of kinetic friction is how much? You have applied 85 Newton. Okay, 85 divided by M into G. Mass is 40, same, and G will be 9.8. Okay, so therefore your answer will be, now this is the last sum, so that is 9.8. So therefore 85 upon 0, 4 8s are 32, 3 9 4s are 30, means 392 again, and 85 upon 392, that answer will be 0.2168, 0.2168. Okay, so what is the unit for that? There will be no unit, because this is also 4, this is also 4, so therefore it is a coefficient. Okay, so that is the way how you have to solve this problem. Okay, so the next period we can go for the friction in liquids, that is the pressure. But now tomorrow we'll see that things. Today we'll stop here. Okay, that's all.